So I'm going to make the axle doing extrusions. And then I'm going to make the axle using revolve. Okay? So let's do extrusion first. So I'm going to make a sketch on the front plane. And I'm going to draw a circle. This circle is going to represent the outermost sides of this object. So I'm going to get my calipers on there, pushed up against the wood, and it looks like it's about 10.5. Okay? 10.5. So I have my circle. Now, to get the height of it, I am going to use the thing that sticks out of the bottom. It's not perfect, but somewhere around 1.7, 1.8. So I can extrude this 1.8. And I have now the bottom. Now, if you look carefully, the top part has a little bit of a lip at the top. So I'm going to have to do this as multiple extrusions. So I am looking at, this was like the top of that piece, so to speak. I placed another sketch on top of it. So I'm going to have to do like another extrusion. And the diameter of this circle is the diameter of most of it, basically the part that goes inside the wheel. So about 7.4, somewhere around there. And what I'm going to do, I think the best way to do the lip is to actually, because I have to measure this stuff, right? I think the best way to do this is to go all the way up, do the full height, so it looks like about 11.4. Okay? And what I'm going to do is I'm going to extrude the lip down. I'm going to extrude the lip down. So this top right here is in fact the top. But that little lip that sticks out some, what I'm going to do is I'm going to sketch on top of this. And I'm going to draw a circle that's a little bit fatter. Just a little bit fatter. And we're going to go with that. This one is just a hair fatter. 7.5 maybe. Okay, so maybe what I'll do, because there's a little bit of measurement error in here. Maybe I'll make this one. This one's 7.4. Well, no, that was 7.4. I made this one 7.5. All right, that's right. You can see there's a little bit of gap there, just a little bit. So what I'm going to do is I'm going to extrude that ring that's basically forming the lip. I'm going to extrude that one actually down. So I'm going to change the direction, and I'm going to get the height of that lip. And it's not very tall. Maybe 1.2 or 3. Let's go with 1.3. So you can see I changed the direction. It's getting extruded. Oh, that was 13. I don't want 13. 1.3. You can see it's getting extruded down. I think it was just easier to measure the overall height first. So I have my base. I have the shaft that sits outside of the wooden section. And I have this little lip here. Now what I have to do is I got to extrude and cut out basically holes. And if you look, you may notice that actually there's like 2 holes. Do you see that? Like if I go down a little bit, it's wide and then it narrows up. So I'm going to extrude on the top. I'm basically like drilling down. So to get that diameter, I can use the top teeth of the caliper. to get the hole width somewhere around 4.8 maybe. 4.8. And I can extrude down. I'm going to cut down. So I got to reverse my direction. And it's going to be remove. And how deep, I'll use the thing that sticks out the bottom. And I will measure how far that goes. That's about 6.1. Somewhere around there. And if you look, you'll notice then that the next hole is a little bit narrower. Unfortunately, I don't have a way to really measure that because there's no way to get my calipers. That's not where I wanted that hole. I don't have a way to get my calipers in there. Why is this being a butt? So I'm going to draw my hole, and I am going to dimension it, but this is going to be a very ballpark dimension. Like I don't really know how wide that hole is. I have no way to get my calipers in there. I'm just gonna, so I'm going to kind of just eyeball it. Maybe it's 3. I don't know. Not really sure. There's no way to get in there. But let's just go with 3 maybe. Yeah, let's go with 3. And I'm just going to assume that goes all the way.
Hey, I'll be back. Yeah, where are those small screws?
What screws?
The smallest ones. The one you gave me when I was small enough.
The bag right here. Are you attaching a 90-degree box or something?
Yeah.
Yeah, these are the ones you use for that.
There. Hopefully, them.
Well, I guess I got to change the direction. There we go. So you can see, you could sketch. I sketch on the front plane, so you could sketch on this surface for that hole, or you could sketch on this surface for that hole. Doesn't really matter. I just made it go all the way through. So you can see in the extrusion that I went up to next. I went like through all that. So that is the top half, mostly done. I won't say that it's perfect. I kind of just quickly measured things, and then there's no way to get that inner diameter. But that's the top half. Now for the bottom half, we could just sketch a cylinder on there. I could do a ring. So I'm going to make these two match. And then how much should this be? I mean, I could make it match this if I wanted to. So maybe, like, for example, what I could do is we could project this cylinder onto, I'm actually going to technically have to be that edge. I could project that cylinder. I actually don't even need to draw that circle then. I could actually just project both of these. I lied. Apologize to you and your family's dog. So I actually don't have to draw any circles. I could just project this and project this and just assume it's the same size. May or may not be accurate. And extrude that a decent size. I don't know how far it's going to be. Let's just say 10. And that's what goes in the view. That's what goes inside the car. Okay. Is that accurate? I don't know. I don't have the ability to take it out. I've never taken one of these out. Okay. I'm not going to be too picky about what goes inside the car. You could just do a cylinder. For the top part, I measured the best of my ability. How many extrusions did it take me to do that? How many extrusions? How many extrusions? What's it say on the board? 6. How many revolves would it take?
Probably 2 or 3. 6. 7. 7.
How many revolves would it take to do this?
Million. 1.
1. I could do this in 1 revolve. So you all tell me, what do you think is better, revolve or extrusion?
What?
Took 6 extrusions to do this. If I do a revolve, I can do it in 1 revolve. What do you think is better?
Well, which one of these?
I mean, I'll be honest, if there was like 2 or 3 extrusions, I don't know that it really matters that much. Because the time it takes to draw the profile for the revolve is a little bit more. But 6 extrusions, I don't know, man. A revolve might have been a smarter choice. Okay? So, I'm going to delete all this. All right? I'm going to delete all this. Won't let me select multiple things. Unfortunate. I just have to delete them one by one. We're going to delete all this, and I'm going to do a single revolve. So I'm going to draw on the front plane, like I did before. First thing I'm going to do is I'm going to draw a vertical line that touches the origin. Frankly, I don't really care how long this line is, but it needs to be vertical, and it goes through the origin. And we're going to use this to revolve around. So what type of line should we make this then? We're not actually making it as part of our object. We're using it to help us construct the revolve. What type of line should this be then? What do we call those lines that help us make our things? You guys remember? Oh boy. What do we call the lines we use?
What lines?
To help us make stuff? They're like dash.
Oh, construction lines.
Construction line, very good. Right here, construction line. Huh?
We're supposed to make people.
No. I've never expected people to make those. So that's the construction line. And then what I'm going to do is I'm going to draw the profile. So I'm going to use the line tool to do this. So I got the widest point, vertical constraint being automatically applied. And then I go in a bit. And then I go up. And then I have a little lip. Go up. And then I go all the way over. Actually, I lied. I don't go all the way over. I go over some. Now the top hole is wider. And then it tightens up some. And then I don't really know what happens down here. So I'm just going to assume that it is... Turn that off. There's a generic cylinder down there. I did that. You can go back and watch the stream if you didn't catch, but I basically automatically applied constraints that I want without applying anything I don't want. So, as an example of something that could happen, if you put this line that I'm dragging around right now too close to this line, or this line, or this line, basically if any of your vertical lines happen to accidentally line up, it might auto-constrain the V lined up, and you may or may not actually want that. Same thing with this horizontal line here, and this one here. I don't want those to line up. Now I'm just going to dimension stuff. So the first thing that I did was I got the overall diameter of the biggest part, and that was about 10.5. Now that's a diameter. So when I dimension in, I actually place a dimension. I'm going to click on this construction line, but then when I click to place a dimension, notice if my mouse is over here, it's a diameter. Over here, it's just a distance between the two. I'm going to go over here to make it a diameter and 10.5, and you can see that that actually treated as a diameter, which is nice. I don't have to do any math then. And then I'm going to do the other diameters. So this lip, you may or may not remember, I did 7.5 earlier. Might change that, tune it up. And then this one, I did 7.4. And then I'm going to just do this. I'm going to just line these up. I'm going to line with a vertical constraint. I'm going to line this up with this. So I'm just going to line these two dots up and just say that they're the same size. And I don't really know if that's true or not, but it is what it is. Now for the holes, this one, I can do. Okay, the width of that hole was about 4.7. And then the width of this hole, I just kind of ballparked it and said it was about 3. I don't know if that's right or not, but we're going to go with that. So I have all of my diameters. Notice that all the vertical lines are therefore black. They're constrained. So now it's just about getting heights. So I'm going to get the height of this lip up here. It's like 1.4. Okay. And then you can see that's still blue because I have not constrained how tall this is. But if I do that, it's going to turn black. So I'm going to get the overall height right now. I'm doing this using the thing that sticks out of the bottom. Maybe 11.6. I don't know if that's exactly what I measured last time, but that's what I'm going to go with. And then I got this little lip at the bottom. I'll use the whole thing. Looks like it's like 1.9, maybe 2. I'll go with 2. I think I might have maybe measured it not so well last time. And so this is locked in. It's black. Okay, there's no blue there at that lip. All I really do is got to figure out how deep down I have to go inside before the thickness of the hole changes. And it's about 6.3. So that's what I'm going to measure this to be. Now, it took a little bit more time to do this sketch than it would have if I, had done extrusions, but I think it pays dividends. Because now I'm done. All I got to do is revolve this. To revolve it, it prompts you to select a face or sketch, revolve that, and then it says revolve axis, and I'm going to choose this construction line I had earlier. And in one fell swoop, I'm done. We didn't really talk about how tall this is down here, but what I could do is I could try and mirror it. I could say that it's like the same. It sticks out as much as it goes in. I could do that if I wanted to. You can make that whatever you want. You can just all just ballpark it and say, 10, that looks good. Sure, 10. I don't know if it's right or not, but I can go with it. Questions before I do the last part? Okay, so there's these little notches, these little holes. Now, in my opinion, the easiest way to do that is to sketch on a plane. So, for example, I could sketch on this front plane a rectangle right here and then just cut both forward and backwards. And that's exactly what I'm going to do. I am going to sketch on this front plane. I'm going to do a rectangle. I'm going to do a center point rectangle. You'll see why in a moment. I'm going to do a center point rectangle. That way I can line the center up automatically and make it symmetric about the center line of this overall shape. Just place that center of the rectangle in the center of the shape. I'm going to use a project to project this top edge just so that I can have a coincident constraint to make this line lie on this line. And so now it's just about getting the width and the height. So maybe 5.4, 5.5 maybe. The height and the width. This one's a little tricky. You're going to have to do a little bit of ballpark in there. Looks like it's about 1. I'm just going to go with 1. And there it is. There's my sketch. So I got that little rectangle. It's kind of drawn like almost inside the shape. And then when I do an extrude, I'll just extrude. I'll do a remove. And I will go both directions. I will go symmetric. And just go through all. Yes. Now we talked about through all a long time ago. When you do a through all, it cuts through everything that exists at that moment. So if you add stuff later on, it's not going to magically cut through that stuff after the fact. I could also choose up to face, and then I could click on this outside of the cylinder. I could do that. But there's no symmetric. I had to do a second end position. I don't like doing that. So I'm just going to go through all. That's the easiest. And there it is. My axle is done. We have questions? Okay, I'm going to stop the stream then.